All right, lesson 5-3. We're going to start right in by doing another proof problem. So in this problem, we are being asked to prove the triangle AVE is congruent to triangle TVK, the only two triangles in the picture. We've been given this information that angle EAV congruent to KTV. We should mark those parts. Remember, anytime you have a statement about congruent angles or congruent segments written in the statement column, you should put the marks about those congruent things in the diagram. So we will mark this angle congruent to this angle here. Okay, that takes care of that. V is a midpoint of AT, it says. Now, you might be tempted upon reading that statement to go mark some other congruent things in the diagram, but this statement does not literally say that anything is congruent to anything else. The word congruent does not appear in that statement. The congruent symbol does not appear in that statement. Okay? But I see this happen to students all the time. They so quickly in their mind conclude from this statement what they know to be true on the basis of that statement, that they will mark other congruent things in the diagram without explaining why. And the proofs are all about the explaining. Okay, so you have to, on the basis of this statement here, write out a step 2 and say that AV is congruent to VT because, here's the explanation, if a point is a midpoint of a segment, I'm using lots of abbreviations here. You are welcome to also. I don't mind abbreviations as long as it's clear what they are abbreviations of. If a point is a midpoint of a segment, then it divides that segment into two congruent segments. Oh my goodness, I do not understand why my screen freaks out like that from time to time. Come on, eraser, where are you? Oh, and now my stylus has gone dead again. Come on. Into two congruent segments. All right, I don't think that's going to happen again. Two congruent segments. That's the reason, right? That's the explanation. And remember, you can't use a reason like this one that begins with if a point is a midpoint unless we already know that a point is a midpoint. Right? You don't have to circle your hypotheses and connect them back to statements to get full credit from me when you write up a proof. I just think it's not a bad idea to do that, to check yourself, or even to show me, hey, Mr. Nortillo, or whoever your teacher is, I've been checking this work here. Here's how I know that it's good, all right? So right now, we're trying to get these two triangles congruent to each other, and we have, at this point, two pairs of congruent parts. We have one pair of congruent angles and one pair of congruent sides, and that's all we have right now. And I think you know by now that we have three ways of concluding that triangles are congruent: SSS, SAS, and ASA. But all of those ways of concluding, all of those reasons for concluding that triangles are congruent require that we already know three pairs of congruent parts, and we only have two. So it might seem that we are stuck on this problem because we've used all of the given information. There is no more given information to take advantage of. How else could we conclude that there are any other congruent parts in this triangle? Now, if we were in the classroom, I would invite people to start suggesting, are there any other congruent parts that we could get? And we'd probably dance around that question for a little bit. And people would give me all kinds of bogus reasons, bad reasons for knowing that other congruent pairs of parts exist in this diagram. There are almost no good reasons for concluding that there are any other congruent parts in this diagram. But I did say almost. There is one reason to know that one other pair of parts from these triangles are congruent, and only one. And some of you might see it. It's a reason that we have not used in proofs before, but you have applied this reason in other problems before. Let me give you a quick tip. Here's a couple of triangles, and I say that this angle here is 66 degrees. Can you tell me what the measure of that angle right there is? Of course you can. It's 66 degrees. Do you remember why? What is the explanation for that? What do we call these two angles that are directly across from each other on the opposite sides of two intersecting lines? We've got a name for those kinds of angles. Who remembers? They are vertical angles. And anytime we see vertical angles, we know they are congruent, right? So here's a reason now that we're going to use in our proofs starting today. And it's a slightly unusual reason, which we'll get to after we record it. But this angle right here, angle AVE, is going to have to be congruent to that angle there. Angle AVE has to be congruent to angle TVK because they're vertical angles. And here's how we're going to write the reason. If angles are vertical angles, then they are congruent. Okay? Now here's what's unusual about this reason. I've been telling you, every time you write a reason, you better be able to circle the hypothesis and connect it to some statement in the statement column that literally says that thing is true. Is there a statement in the statement column before step 3? I mean, you can't look at step 3. Remember, you got to connect the hypotheses in your reasons to previous statements. Are there any statements in steps 1 and 2 that declares these two angles to be vertical angles? Do you see the words vertical angles anywhere in statement 1 or 2? No, the answer is no. Okay. So by the rules that I've been giving you and enforcing on proofs, it would seem that we're not allowed to use this reason, but that's what makes this reason different from all of the rest so far. This is one reason that we will allow ourselves to use just on the basis of seeing the vertical angles in the diagram. Okay? So we are still connecting this hypothesis to something that is already true. But in this one case, it's something that we know to be true just because we can see it in the diagram. Remember, there are very few things that we are allowed to assume in diagrams. You are not allowed to assume that that is a right angle just because it looks like a right angle. You are absolutely not allowed to assume that segments are congruent just because they look congruent. You're not allowed to assume that points are midpoints. You're not allowed to assume that anything is being bisected unless you're told specifically, right? None of these things. But when we look at a picture, if we see what appears to be vertical angles, we are allowed to assume that they are vertical angles. And so that can be our reference, the diagram itself. Okay? So now we have a third pair of congruent parts. And now we have enough parts to say that the triangles are congruent. Triangle AVE is congruent to triangle TVK. And what's the reason? Is it SSS, SAS, or ASA? In this case, it is ASA. Okay, if ASA, then triangles are congruent. By the way, if you're doing a proof and you're supposed to say if ASA and you say SAS, It gets marked wrong, okay? Because when you write SAS, you need to have two pairs of congruent sides and a pair of congruent angles. And if you don't, you're quoting the wrong reason. It's wrong, okay? Notice this proof now took us a step 2, a step 3, and a step 4. This is the first proof that we have looked at that has required 3 steps after the given information. And I'm here to tell you, on the homework tonight, you've got 8 proofs to do, and half of them will go to a step 4. Some of them will go to a step 3. Some of them will only go as far as a step 2, and then you should be done. But as I said last time, I'm not going to tell you in any problems from here on out. I'm not going to tell you how many steps they are supposed to take. They will take as long as they take. And until you get 3 pairs of congruent parts. Did we get a pair? Yeah, we got a pair of angles that was given to us. We got a pair of sides from the midpoint, and we got our 3rd pair of parts, the angles from the vertical angles. Until you get 3 pairs of congruent things in that statement column, you're not ready to declare triangles are congruent. And every single homework proof is about trying to get triangles congruent. That's the last statement in every single proof. You got to get 3 pairs of congruent parts. So however long, however many steps it takes you to get those 3, that's how long the proof is going to take you. Maybe I give you all 3 pairs of parts that you need right in the given information. And then step 2, you write it out and you're done. Okay? But this is a new reason right here. We're going to add that to the yellow box before this lesson is over. The yellow box with all the reasons that we can use, we're going to write that in there. Okay? So that's a new reason. And then we're going to do this proof, and then the lesson is mostly over. Okay? Trying to prove triangle FMR, that's this skinny triangle up top here, congruent to triangle XMR, that's that skinny one down below. Here's another triangle over there, triangle FMX. And then, there's the big triangle FRX also, but we're trying to get these 2 skinny ones congruent to each other. We have been given, it should say given here. I noticed a homework problem that didn't say given here. I didn't really mean to leave the word given out. I'm not going to be quizzing or testing you on whether you know that that's first reason is supposed to be given. The first reason is always given. If you're not given any information, you can't get anywhere. Okay. So angle XFR, that's this one, is congruent to angle XFR, and FXR, that's this one. And then FM is congruent to MX. Okay. Now we're trying to get these 2 skinny triangles, FMR and XMR, congruent to each other. How many pairs of congruent parts do we have in those triangles? Hold on, I'm going to ask that question again. Listen carefully. How many congruent pairs of parts in the 2 triangles we are trying to get congruent? How many pairs of congruent parts do we have? It's not 2. We only have 1. Only 1 pair of congruent parts that belong to these triangles, and that's these segments. These angles that we were given congruent, this angle up here, XFR, is not a part of triangle FMR. Okay, I've talked about this in an earlier video. The only things that we consider parts of a triangle are the sides of the triangle and the angles that are inside the triangle. Okay, if we extend this line out here and we're talking about that angle over there, that's not an angle inside this triangle. Okay, and this whole thing is not an angle which is part of the triangle. So these angles that we've been given are not parts of the triangles we're trying to prove congruent. And so they would almost seem like useless information, but they're not useless. We're going to be able to take advantage of those congruent angles. Let's consider that we have to get 2 more pairs of congruent parts in these skinny triangles, FMR and XMR, because we only have one. First way to get another pair of congruent parts would be to say that segment FR is congruent to segment XR. FR congruent to XR. But I wonder if anybody can tell me the reason why. It's not because they look congruent. It's not because there are any midpoints anywhere. I have no information of midpoints. I have not been told that any triangles are isosceles. Okay? But there is a reason. There is a convincing reason that is relevant to this situation that we can apply to this situation. Here's the reason. If a triangle has 2 congruent angles, then it has 2 congruent sides. Now, which triangle am I talking about that has the 2 congruent angles? It's this triangle here. Triangle RFX. You see that angle that was given to us and that other angle that was given to us, they are angles of that big red triangle that I just highlighted. So that big red triangle has 2 congruent sides in it. Okay? The good thing for us is those 2 congruent sides also happen to belong to the 2 blue triangles that I highlighted initially, the ones that we are trying to get to be congruent. That one and that one. So now we have 2 pairs of congruent parts in those triangles. They're both sides. They're both pairs of sides. And now we need a 3rd pair of congruent parts, right? There's no midpoints. We're not told about midpoints. We're not told about angles being bisected. There are no vertical angles in this picture either. Okay? And so again, it might seem like we are stuck. And that's because I have to introduce to you yet one more new reason, a reason that is not based on statements already made in the statement column, but another reason that is based on something that we can see in the diagram. Okay? And so here's what I'm going to say. I'm going to say segment MR is congruent to segment MR. I did not make a mistake there. I named the same segment twice. I'm basically saying that a segment is congruent to itself. Okay? And here's how I'm going to mark it. I'm going to put a triple mark in there because I don't want a single, I don't want a double. Now in the diagram, that's only one segment. It's only one side. But that side belongs to both of the triangles that I'm trying to get to be congruent to each other. And so in this case, that one segment or that one side is acting like a pair of sides because it belongs to the 2 triangles I'm interested in simultaneously. That one side belongs to both of them. And so here's how I'm going to write the reason. If a side is shared by 2 triangles, then it is congruent to itself. Okay? And again, this is something that we can see in the diagram, the side being shared by 2 triangles. Right there. That segment MR belongs to both of them. If a triangle has 2 congruent angles, that's something that we were given here. Okay, so I'm still able to connect this reason to something that we know. In this case, the way we know it is from the diagram itself. So both of the new reasons today are reasons that we can use when we see certain things going on in the diagram. Okay, now I'm going to warn you about how not to use this reason here, this new reason here, because I can't tell you how common it is for students to use this reason at the wrong time and in the wrong way. Okay, the vertical angles one, I don't see students misusing that one very often. But this reason here, I see it being misused a lot. Okay. At any rate, here now is the updated list of reasons, a new yellow box, updated to include 5.3. That's this lesson here. And there aren't going to be any more reasons that we are going to add to this list. We've got two more lessons. No, we've got one more lesson coming. We've got a 5.4 lesson coming. And we're going to do more proofs. And believe it or not, the proofs are going to get even longer. Okay. But we're not going to need any more reasons to be able to do these longer proofs. So this is it. This is the final list. Okay. And the two new ones I've highlighted in green down at the bottom of this box here. On tonight's homework, which I think I want to give you a preview of here, you should be looking for the opportunity to use these reasons here. In about half of the proof problems tonight, you're going to need one of these two reasons. The other half of the proof problems, you won't need one of those two, but you'll need all of, some of the other ones. Okay, so be on the lookout for those. In fact, let's go take a look right now. I want to bring up the homework. Let's see. Okay, we're looking for vertical angles, or we're looking for a segment that is shared by two triangles. Here's where the proof problems start. Do you see any vertical angles in this diagram? Yeah, I do. You're going to need that new reason for that proof. You see any vertical angles in this diagram here, in this proof? No, there aren't any. Do you see any segments that are shared simultaneously by two triangles? Well, I do. Okay, but look, here's an example. Segment OV. That segment is part of triangle OLV and OMV. But do those triangles look like they are congruent to each other? You should be shaking your head. No. Those triangles, this one up here, OLV, and this one here, OMV, they don't look anywhere near congruent to each other. So while I could say, hey, segment OV, since it's shared by two triangles, is congruent to itself, it's probably not going to be very useful to me. Okay, not very helpful to use that reason unless the side that you're talking about belongs to two triangles that you are trying to get congruent to each other. Look at this problem. VOL congruent to VUS. VOL, that's this triangle up here. We're trying to prove that that skinny triangle up top is congruent to this skinny triangle up top here, VUS. Those two triangles do not share any sides in common. Trust me, there will be no opportunity to use that reason in this proof. How about the next one? You see any vertical angles here? Any vertical angles? No. Any sides that are shared by two congruent looking triangles? Yeah. BC right there. Okay. Next problem. Any vertical angles? No. Any sides being shared? No. This one here. Vertical angles? No. Any sides being shared by two triangles simultaneously? No. The answer is no. Look, we're trying to get triangle BLG congruent to DRG. BLG is this triangle over here. DRG is this triangle over here. Okay. Now, segment BD, all right, goes from one of those triangles to the other. But segment BD is not a side of either one of these triangles here. It's too much of a segment. Okay? A side of triangle BLG is BG. That's it. And a side of the other triangle is GD. That's it. And neither one of those segments, BG or GD, is being shared by two triangles simultaneously. So no opportunity to use that reason in this proof. And you've got segment GL. Well, that's shared by two triangles, GLB and GLR. But look at those two triangles, GLB and GLR. Did they look like they're congruent? They don't look like they're congruent. No. And I haven't asked you to prove to me that they are congruent, despite the fact that they don't look like they're congruent. So there is no opportunity to use that reason in this problem. Let's move on. You see any vertical angles here? Vertical angles? Yeah. Any sides being shared by two triangles simultaneously? No. This one here? Yeah. Here again is a side right there. I am being shared by these two triangles on the left and the right simultaneously. I don't see any vertical angles in that problem. No vertical angles here. No sides being shared here. Okay. Let's go back to the notes. Yeah, where are the notes? Notes here. And I want to just show you one more picture here. Here's what students very commonly do. In fact, this picture looks a lot like, I think, one of the last proof problems we were just looking at. Here's what they will so commonly do. They will say, they'll write this reason. If a side is shared by two triangles, then it is congruent to itself. Okay, and they'll mark TL, congruent to itself, and they'll say TL is congruent to TL. Now, first problem with that is that segment is not shared by two congruent looking triangles. Now, it is shared by two different triangles in this diagram. TL is a side of triangle TLM. It is also a side of triangle TLR. So it is being shared by two triangles, although those two triangles definitely can't be congruent to each other. And it is congruent to itself. Okay. And then they'll use the same reason to say that TR is congruent to TR. And then here's what they'll do. They'll compound their confusion by using the same single tick mark to mark TR congruent to itself as they used to mark TL congruent to itself. And now, guess what these students think they have proven? They think now that they have proven that these two segments are congruent to each other. I see that all the time. Okay? Try not to make that mistake. Okay? One last word about this reason here. You don't even really need a segment or a side to be shared by two triangles in order for it to be congruent to itself. The fact is, anything is congruent to itself. Anything that can be measured is congruent to itself. How could it not be? Right? But the reason, and in a lot of geometry courses, rather than writing out the reason the way I insist you write it, if a side is shared by two triangles, then I insist you write it out this way. In a lot of geometry courses, and I have even taught this in different geometry courses, instead of writing this whole thing, we'll write this phrase, reflexive property. Okay? I've actually seen some students who tried to learn this proof stuff online instead of watching my videos. Bad idea. There were a couple of students who wrote this in their proofs on the last quiz, and it got marked completely wrong because it was wrong. They wrote reflective property. That is a different word from reflexive property. Okay. So it's wrong on that basis when they wrote that. In the second place, that would have been the wrong reason to write anyway in the problems on the last quiz. Okay. I'm not going to explain what that even means, where the word comes from or anything. I don't want you using it. Okay. Because again, even though you can declare any segment to be congruent to itself, you don't really need it to be shared by two triangles. It's of no use to us to say segments are congruent to themselves unless they are shared by two triangles. So don't do it. Okay? That's it. The homework's going to take a while. Don't give yourself 20 minutes to try to do it. Be prepared to invest some time in it. All right? See you next time.